This is video 4 in a series where we're making asteroids as a practice test for my students. Currently we're on step 14, but I realized that in steps 12 and 13, I had forgotten to remove the bullet. Now it says that on your copy, but when I did video 3, I didn't say remove the bullet. So if you don't remove the bullet, here's the problem. So let me run the code. When I fire bullets at asteroids, the problem is that the bullet keeps going through the asteroid and it destroys the smaller asteroids like automatically. So it's not very fun because if the bullet is allowed to keep going, it just destroys anything the asteroid makes. And so it's not quite as cool. So I don't like that bullets can just keep going through the entire world. It's not as fun. So we're going to change this and remove the bullet when it hits any kind of asteroid, whether big or small. So to do this, if you haven't done it already, under asteroid, here's the code that says find out if we're touching a bullet, and if we are, play sound explosion, create new asteroids, add them to the world, and then destroy the bigger asteroid. Well, just before removing the bigger asteroid, why don't we also remove the bullet? So it's going to be the same code. Ask the world to remove Joe the bullet. Remember, that's up here. So Joe is the actor. That's the bullet that we're touching. So remove Joe the bullet and you're good. Do the same thing with small asteroid. And when the small asteroid touches a bullet, remove Joe the bullet. And this will be way better. So now the bullet stops whenever it hits an asteroid. And so here it's way better. So now anytime you hit an asteroid, for sure it's going to blow up into smaller asteroids. So that's a lot more cool because the bullet just doesn't automatically kill everything in its path. And I like that a lot better. All right, continuing with step number 14. So in step 14, it says add a score actor, set its image to nothing, so no problem there. Let's go ahead and right-click actor, new subclass, call this score and no image. Okay. Then next, in the score code, add a global variable for int score to keep track of the actual score. So open up our score code. Let me resize my window so that you can see this easier. So in our score code, let's add a global variable, int score, and initialize it to 0. And then let's add this function to our score code. So here's the act function. We don't need the act function for a score, so let's just delete that guy and go straight to adding our custom function. All right, so here's what the add function should do. It should add whatever the person passes in as the parameter, it should add that amount to the current score. So we're going to say that score now equals whatever the score was before plus amount. So effectively, this add method will just take the score and add this much more to it. Okay, also, we need to update the score's actor image so that it actually displays on the screen. So to do that, we're going to go ahead and create a new Greenfoot image that's roughly 100 by 330. You can change the size if you want. To create a Greenfoot image, let's go to the API and find out how to do that. So here's the API for Greenfoot image, and here are your choices. These are all the constructors or ways to make a Greenfoot image. The one that we're going to use is this one here. You pass in a width and a height, and it makes a blank image of that size. So for us, let's go back to our score code. So after increasing the score, let's make a new Greenfoot image. So Greenfoot image, let's call this IMG, whatever you want to call it, equals new Greenfoot image. And now we got to pass in a width and a height. So for width, let's say it's 100 pixels by 30 pixels tall. It's your choice, however big it is. So this will create a new Greenfoot image called IMG. And next we need to set the drawing color of the image to whatever we want. And so under the Greenfoot Image API, you can find out, so IMG, let's make this Joe. That way I can just refer to him as Joe. So Joe is a Greenfoot image. The things that Joe can do are listed here under the Greenfoot Image API. So here's all the methods or things that it can do. You can clear the image, you can draw a picture inside of a picture, you can draw lines, ovals, and so on. What we wanted to do was set the color. So there is a set color method right here. And the set color method, you say set color and you pass in a new color object. So joe.setColor, and I have to pass in a new color. So you've already seen code like this, color.yellow, for example. That would be a pre-built-in color that Java already knows about. If we try to compile this, there's a problem. And you can see down here it says, cannot find symbol variable color. That's because color is not imported by default. So to use color, you have to tell Java that you want to import that code. So like here, you have import greenfoot.star. This lets you use the actor functions, the world functions, the Greenfoot image functions, because they're not built-in Java things. Color is similar. Color is not a default Java function. You have to tell Java that you want to use the color class. So to find out where it is, here's the pattern always. Go to Google and type in Java Color API, and that'll take you to the Color API. And this tells you what to import. So to do class color and use it, you have to import this, java.awt.color. So back to our score code, import java.awt.color, and that way you can use the color class. All right, so now if we compile, there's no complaints. Java knows what color.yellow is. And if you look at the API itself, you can see there's color.black, whether capital or lowercase, blue, dark gray, and so on. These are all the built-in colors. If you want, you can also use the constructors to make your own custom color. So later on in this video, we'll be using this constructor here, where you pass in how much red, green, and blue is in your color, and you also pass in a transparency as the fourth parameter. But for now, yellow is sufficient. All right, so we've done that. Next, we need to draw the string score on the image. So to draw a string, here is the API for Greenfoot image. There's a drawString function, and to use it, you pass in a string, like hello or whatever you want, and then a position to draw. So let's go ahead and go to our score code and say joe.drawString. Now for now, I'm not going to actually draw the score. I'm just going to say hello and change it later. One thing to know about the position is this. Let's say your score is here. 100 pixels wide is the width, and 30 pixels tall is the height. Fine. If you say drawString hello at position, say XY, whatever that is, here's where it appears. If you say hello here, this X and Y position refers to the lower left corner of your text, right here. So you need to be aware of this, because if you put, for example, 00, 00 you'll never see, because 00 is here, and it would draw the string up here at 00, and that's outside the actual image. So let's say for X, let's put this at 10 units from the left edge. And for Y, let's put it close to the bottom edge, but not quite there. So instead of 30, how about 25? And then last step is we need to set this actor's image to the image we just made. So we just took the time to make an image called Joe, and now we're going to set our image to Joe. And so the image for this score actor will be updated to be this Joe image that has hello in it. All right, finally, add a default constructor to the score class and have it call add 0. All right, so remember a constructor is a method that has the same name as a class. So public, since we're inside the score code, it's got to be called score, no parentheses or no parameters for us. And inside here, we're going to call add 0. That way, when you create a score by default, it calls add 0, which effectively is going to basically update the image to be a score of 0 to start with. For now, it'll say hello. That's fine. All right, so now we need to add a score variable to the world. It doesn't say to do that here, but I'll update my notes to say that. So that the version you get will actually do that. So under our asteroid world, we need to do the same thing we did for ship. So we added a ship object. Let's do the same thing for a score. All right, so let's make a new score object. Score, we'll call it score, equals a new score. That creates a new score object. We'll add it to the kind of the upper left-hand corner of our screen. So let's say for X, I'm going to go 50 and 50 just for now. And let's find out where that is. So if I compile this, oops, okay, 1025. So compiling, you can see that hello is written in the upper left-hand corner. That's cool. So now we'll change it from hello to actually be our score. So in the score code, instead of hello, we want to say score and then plus score. That'll add our score to the upper left-hand corner. So recompiling. So now we have our default score of 0. Cool. Let's move it up a little bit. So let's shift this up. And so the place we added it, 50 was fine for X, but for Y, let's make this say 20. Let's see what that looks like. It should be a better spot. Yeah, much better. So I'm happy with that. Um, Also, let's add a background to the score because yellow isn't so awesome and I'd like a background there. So let's go to the score code and to add a background, once you create the blank image, let's go ahead and set the color to a custom color. All right, color C equals new color. Now normally you pass in how much red, green, and blue to put. Let's create just white text. So 255, 255, 255. But then to make it transparent, the fourth parameter here is the transparency. Let's say 50 for transparency. That'll be mostly see-through. And let's set the color to this new color. And next, let's do joe.fill. What this will do is it'll fill the entire image with this color. And check this out. If we go to compile and update our visuals, you can see that in the corner now is this kind of transparent background. It looks way cooler. So update the score's position so it's centered in there and looking much better, but for us, I like it. Yellow, let's change the yellow text to white. I think that'll look a little bit cleaner. So instead of yellow, let's make this white, and I think that'll look better. All right, I'm happy with that. So there's a score of 0 so far. Cool. All right, so we're done with steps 13, and I think that we're done with 14 as well. We are. All right, step 15, update our asteroid code to give 50 points when a regular asteroid's hit and 100 points when a small one's hit. So let's first do the first one. 50 points when you hit a regular asteroid. So let's go to the asteroid code. Now we already have code that says here's where we've hit an asteroid. So now we need to update the score. Well, the problem is we can't access the score currently because the score, if you look at Asteroid World, the score is a local variable that's only known inside the constructor. So let's change this. Let's make this a global variable. Instead of declaring score here, let's make score be a global variable and declare it up here. So here you declare the score, and down below you just initialize it and use the constructor. So now score is accessible as long as we do some typecasting. So back to the asteroid code. All right, once we hit an asteroid, that's this section of code. So after doing all these things about playing explosions and removing things, let's update our score. So normally we like to do this, just say score.add, and then we want to add 50 points for a regular asteroid. This would work except for Java doesn't know what score is because there is no score variable inside this current class. The world has it. So ideally you could just say get world and have it know the score. But the problem is that get world, it returns an object of type world, not asteroid world. So a regular world doesn't have a score, only an asteroid world does. So you have to convert the world into an asteroid world by using typecasting. So to do this, as always, to typecast, you surround the thing you want to convert with parentheses, and outside that, you put the new type. Our new type is asteroid world. So this will convert the normal world into an asteroid world. Then surround this whole thing with parentheses. So now this whole thing is an asteroid world, and it can then access the score. So it's a little bit, it's messy, but that's how to convert a regular world into an asteroid world, which an asteroid world has a score. So there's that. And let's do the same thing for a small asteroid, but for small asteroids, we're going to get 100 points. So after doing all this removing object stuff, let's add 100 points to our score. All right, compile. Let's see if this works. So our score, you can see in the upper left corner. If I hit an asteroid, then, hey, no pointer exception. All right, let's find out what happened. So let's go to asteroid line 54 because we're crashing on line 54 of asteroid. So here's asteroid. Line 54 is here, and here's the problem. So the problem is that we tried to say get world on the asteroid, but we've already removed the asteroid from the world. So once the asteroid's removed from the world, it doesn't have a world. So we need to change the order of the code. And instead of asking this here, before destroying ourselves, we have to actually add the score. So let's just do it right before killing ourselves. There. So remove the bullet Joe, update the score, and then finally destroy ourselves. And that'll be true for the small asteroid as well. So go to the small asteroid code and move this to before you remove the actual asteroid. All right, let's try this again. Recompile. Let's clear out this error message. Rerun it, and here we go. So if I go and kill this asteroid, then we can see our scores updating with what it should. So we get 100 points for a small asteroid, and we get 50 points for a bigger asteroid. All right, so far so good. Cool. All right, for our final step, step 16, then we'll be done. If the ship's hit by either kind of asteroid, we want to play the game over sound. So that seems easy enough. Let's go to the ship code and ask it if it's been hit by an asteroid and just play the sound. So let's do that first. Open up ship. And here's our code so far. So first let's find out if we're touching an asteroid. So after updating all the location stuff, let's use the get one intersecting object function. So let's go to the actor API. Under actor, we're going to use the get one intersecting object function to find out what actor are we crossing. And we'll save this into actor, let's call this um, test1 equals get one intersecting object, and we want to test out asteroid.class. So remember, to use this, you have to pass in, right back here, let's get to pass in a class type. And the class type we're testing is asteroid.class. So that'll be the first test. Second test will be testing to see if we've collided with a small asteroid. Check. All right, so test one will be an actor of type asteroid if we've touched one. Test two will be an actor of type small asteroid if we touched one there. So if we touch either one, if test one is not null or test two is not null, then that means we've touched an asteroid. And in either case, if we've touched either kind of asteroid, we want to play a sound. So greenfoot.play sound, and I think it was called game over.mp3. And for now, I'll just test this out. So if we run this and I run into an asteroid, you won't be able to hear it, but on my headphones, I'll be able to hear this thing. Let's find out. Yeah, yeah, it's working. So when I touched the asteroid, it did play a sound. So far so good. All right, play the sound, check. Stop the game, that's another thing. So that's easy to do. So to stop the game, there's a helper function under the Greenfoot class. So Greenfoot class, and there's a function here called stop, which just stops the entire Greenfoot game, which you can never restart, by the way, at least not easily. So let's go there. So if we're touching either kind of asteroid, play game over, and then let's call it Greenfoot dot stop, and I'll stop the game. All right, well, there's still more to this. Okay, so we've played our sound. We still need to display a game over message in the center of the screen, but we've already stopped the game. So to display game over, here's the final step. That's then we'll be done with our entire project. Let's create a new actor called game over and set its image to no image. So right click actor, new subclass, call this game over and no image. Okay, then let's add a default constructor that creates a Greenfoot image object that's large enough to hold the message. So let's go there. Let me resize my window so that we can see this easier. So we're in game over, and a game over doesn't really need an act method, so I'm going to delete this. And instead, we're just going to have a constructor that says public game over. And in this constructor, like I said, we're going to create a new Greenfoot image. So Greenfoot image, let's call this img equals new Greenfoot image, and we'll make it the suggested size, although it says whatever size you want. All right, fine. Let's make it 200 by 100. If we need to, we can adjust this later. So we have a blank image created so far. Then change the font color to whatever, we'll change the color of the drawing tool and change the font to whatever you want. So let's use these two tools. All right, for set color, we've already used set color before, so I'm going to go ahead and say image.setColor. Let's set color to, let's see, how about light gray? That's a pre-built-in color. All right, so our color's been set to light gray, check. And now to set the font of the image, we're going to go ahead and use set font. So image.setFont. And inside the parameters, you have to actually pass in a real Java font, like the straight up thing. So looking at the API for, let's go to the Greenfoot image class. So we look at set font is right here. You have to pass in an object of type Java awt.font. So that means let's go to Google and find out how to use a font in the first place. So anywhere you want to type is fine. So Java font API, and here it is. So So to create a font, here are the constructors, and the one we're going to use is this one. So create a font with these properties here. So let's make a font first. So font, and then let's call him Freddy. Let's call it my font, whatever. All right, font my font equals new font, and we're going to pass in these parameters. So for the name of the font, it's the exact same name that you would see in Microsoft Word, for example. So here, let's show you in Word. So here's Word. If I open up my ribbon, these font names here, these are the same font name. So whatever you see here is what you can get. So let's find a font that looks kind of interesting. How about this one? Um, Bohas 93. So whatever's on your system, find out and you can use that. So Bohas 93 is my font name. So back to my code, I'm going to say, I forgot how to spell it already. B-A-U, right, B-A-U-H-A-U-S 93. And then for style, let's go back to the API for font to find out what style choices you have. So here are your style choices. You have a choice of plain. You can do, that's not one. Okay, plain is one. Let's look up here. I'm trying to scan the API real quick so we can find out what the types are. I know that plain is one of them. All right, well, they're here. So here's one style, right? You can say bold. Let's search for style. Okay, so bold's a style, italic is a style, and plain's a style. So let's just use the plain one. Remember, since something is static, that means you use it by saying the class name, in this case font, and then dot whatever. So we're going to say font dot plain for that style. So font dot plain, and for size, that's just the point size. Let's say 60, which is pretty huge. But and now now that we've created a font, we're gonna set the font to the font we just made. Check. All right. So far we have a blank image. It has a light gray color. We have set the font, and we're going to now draw a string. So image.drawString, and we're going to say game over, and we're going to draw this towards the bottom of the image. So how about 20 for the x coordinate, but then somewhere near 100, but not quite. How about 90? And we'll adjust it if we need to. So we need to make a new game over object whenever we get hit. So back to our ship code. So when the ship gets hit, we're going to play a sound. We're going to make a new game over object. So game over, let's call it game over, let's call it Larry. Game over Larry equals new game over, and then we're going to place it on the center of the screen. So let's say get world dot add object. We're going to add Larry to the center of the screen. So get world dot get height or width divided by 2, and same thing for height, but divide that height by 2. All right, so ask our world to add an object. We're adding object to Larry. Larry is the game over, and we're adding him to half the world's width and then half the world's height. Let me make sure I've closed all my parentheses properly. All right, check. So let's try this out and see what we got. All right, so here, color's not imported as before, so we need to import the color API. Import java.awt.color. Java knows about the color class. Font, same thing. Let's go to the API for font and find out where it is. So font is in the same spot, Java awt.font. So let's import that as well. The more Java you use, the more things you'll have to import. All right, let's recompile and see what we get. So recompiling. Now if I hit an asteroid, like this one, all right, so far it's showing just a green foot because I forgot to set the actor's image. So let's go back to the ship code and actually no, it's game over. So go to the game over actor. So we made a new image, we modified its properties and drew a string on it, but we never set the actor's image. So set image to img. That way we update the actor's image to this. That's the way I'd forgotten before. So let's see if this works. All right, here's an asteroid to run into. When I do, cool. So it's working perfectly. The problem so far is that the actor's image is not big enough, and so I need to make the size larger. So to see what we're doing, I'm going to first just fill the background um, with a whatever color. So let's say we do image.setColor, color.blue, for example, and then image.fill. Then we'll be able to see the actual size we have to work with. And it was already clearly too small, so let's make this 300 wide. Try it out again and see what kind of space we have. All right, so far so good. Now it's taller than we need, and so let's make our game over object be not so tall. 100 was too much. 50 would be a closer cut, but 300 is still not big enough. Let's go 400. Recompile, rerun, crash and burn, and let's see. All right, there's one to run into. All right, it looks long enough, and I can see the game over is just barely peeking up right here and here. So the problem here is that we've added it to 90. So if the pixel's only 50 tall, let's add it to like 45. We're really close to the bottom. All right, that's looking much better. And now finally, the width is still too big. 400 was too much. Let's try 350. And let's get rid of this part so that we don't have the blue background. I think this will be sufficient. All right, so we've got the ship moving around. Cool. So it just played the game over music. Game over's added. Our score's working. Everything's going fine. So we've completed. We've done it. We've done all of our goals from the sheet, and that's awesome. So the actual test will be not as long as this. This was way long. The test will be a simpler game and only a few parts. This was a very comprehensive test. So thanks for watching. Take care.